Hi, you guys. As I promised, I said I would go over the study guide, upload it so that you could take a look at exactly how to do these problems. Number 1 starts with an excess of aluminum. I want to remind you that the word excess means you really don't have to worry about the reactant, because the excess means you have way so much of the aluminum that you really don't care about it. It is not important to this reaction, it is important to the reaction, but it's not important to the problem. What is important is 3 moles of bromine. And one of the things that I see you guys doing is you don't write what you have underneath the equation. And it's really helpful in terms of making a plan. Now finally the question says, how many moles of aluminum bromide do we have? So the plan for this problem is to go from moles to moles. The mole-to-mole reaction, or rather the mole-to-mole, what's the word I'm after? The mole-to-mole process, better word. The mole-to-mole process means that you can write an equivalent statement, a conversion statement if you will, that says 3 moles of bromine is equal to 2 moles of aluminum bromide. Which means as a conversion statement, I could write this in the same way I would write 1 inch is equal to 2.54 centimeters. So I can turn that into 3 moles of bromine to 2 moles of aluminum bromide. Or I could flip this upside down. Either way, it is still valid, just like 1 inch over 2.54 centimeters. I could flip this equivalent statement as much as, to suit my needs for solving the problems. So the first thing I need to do is start with what's given. We have 3 moles of bromine that are given in this problem. Well, those lines are nice and straight. Ha, not. So anyway, we have 3 moles of bromine here. The equivalent statement that we're going to use, if moles of bromine are here, moles of bromine belong down here. And we are converting it to moles of aluminum bromide. That's a better line. The equivalent statement says 2 moles to 3 moles. This is the unit we're after, so we're done. We just need to do the math now. Well, I know that 3 divided by 3 is 1, so your final answer, you have 2 moles of aluminum bromide. That's all there is to problem number 1. As I was reviewing problem number 1, I did notice one small error that I made, in that I did not deal with the significant figures of the last problem. So your final answer should have been 2.0 moles of aluminum bromide. My error. Dock me a quarter of a point for failing to look at the significant figures. I'll try not to do that again. Okay, in this problem, we're looking for molecules. And one of the things that seemed to throw a lot of you was the word molecules, because you had to remember the conversion between molecules to moles. Well, 1 mole of anything, it doesn't matter. I wish I had a mole of dollars, a mole of molecules, a mole of dollars, a mole of atoms, a mole of shoes. It doesn't matter. 1 mole, if you're looking for the number of something, is always going to be equal to Avogadro's number. I really hope that you remember that number, 6.022 times 10 to the 23rd of anything that you're after. Okay, so we're looking for molecules of NO2. So underneath that, I'm going to write question mark molecules. Please don't skip this statement. Okay, how much of that is produced when we start with this much of ammonia? So underneath ammonia, 0.5, and I'm going to skip all those zeros for now, even though they are significant. Trailing zeros after a decimal are always significant, whereas a leading zero, this leading zero does not matter at all. But to save some space, I'm not writing it here. I'll check the sig figs later, I promise. So we have 0.5 moles of ammonia. So what is your plan to solve this problem? Why don't you pause the video and see if you can come up with a plan? The plan for this that I'm going to do is I'm going to start with what's given, moles of ammonia. So I have moles of ammonia, and I need to convert that to molecules. And to do that, I need to go from moles of ammonia to moles of NO2. Once I have moles of NO2, I can then convert it to molecules of NO2. Okay, so let's get started. 0.5 moles of ammonia. Trying for a better straight line this time. All right, if moles of ammonia appears here, it must appear down here. That's the only way you're going to get those to cancel. According to our plan, we need to convert from moles of ammonia to moles of NO2. Why don't you try pausing the video and seeing if you can finish the dimensional analysis on your own. The moles of NO2 go here. And I'm going to put the coefficients found in the balanced equation. So here we have 4 moles of ammonia. And here we have 4 moles of NO2. Okay, that made the moles of ammonia cancel. If moles of NO2 is here, it absolutely, moles of NO2 appears up here, you absolutely have to write it down here. Otherwise, it won't cancel. If moles of NO2, okay, so then the plan says now we need to go to molecules of NO2. And I'm going to abbreviate that. Where am I going to get these numbers? Well, for every 1 mole, it's always going to equal Avogadro's number of, this case, molecules, but it could be anything. Could be atoms, could be shoes. But the number that 1 mole equals is always Avogadro's number, which I'm too lazy to write right now. This made these moles of NO2 cancel, and if you'll notice then, we are left with the unit that we wanted in our final answer. So we're ready to finish the problem. Then when you punch this into your calculator, you can cancel the 4s. 4 divided by 4 is 1. So half
is attempting to reach you on your cell.
So I'm sorry about that. So half of 1 mole times Avogadro's number is 3.011 times 10 to the 23rd molecules of NO2. And the problem is officially done. Oh, sig figs, 1, 2, 3, 4. 1, 2, 3, 4. We are finished. And now you can move on to problem number 3. If you have any questions, just jot those down and we will discuss those questions later. The last question on this video asks you to find the identity of X. And the identity of X is not terrifically difficult to find, but one of the things you have to know is molar mass. Well, rather, you need the units of molar mass. And those units are grams per mole. And if you know the molar mass of an element, you can make a pretty good guess about what the element is. For example, if I gave you the molar mass of 22.99 grams per mole and asked you to find out who that was, I'm sure most of you, without a lot of thought, could say, hey, that's sodium, and you would be correct. In this problem, we've been given 175 grams, so we already have X. But what we don't know is the number of moles. However, we have been given 2.43 moles of this unknown substance. And if I know the moles of this, then I can convert that to moles of X. So 2.43 moles of this unknown substance, and I'm going to convert that to moles of X. Again, if moles of X appears up in the numerator, we have to bring that down, or as I said before, chase the unit down before X3, and I'm going to convert that to moles of X. If you look at the balanced equation, there's that invisible 1 there, so we put a 1. And we have a 6 in front of the X, so we get a 6. Plugging it into your calculator gives you 14.58, but if we pay attention to sig figs, 14.6 moles of X. So our final step to finish this problem, well, almost the final step, is you take this number and you plug it in, where did I go, to that equation. So we end up with 175 grams divided by 14.6 moles of X, and you end up with 11.998. Well, let's just change that to 12 grams per mole. Who has a molar mass of 12? Or if you want to get picky with sig figs, 12.0. Yes, that's carbon, and you are done. The identity of X is carbon.